In episode 19 of Mobycast, Chris leads part 2 of a discussion about securing containerized deployments. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Welcome, Chris and Rich. It's another episode of Mobycast.
Hey. Hey, Rich. Hi, John.
How are you doing?
Doing good.
All right. What have you been up to this week, Rich?
So tomorrow I leave for vacation. So the last week has been just finishing up some stuff for the first time in probably my career. I actually planned accordingly and don't have a whole bunch of stuff happening next week. So it's been really calm, which is unusual the week before. And I'm just waiting for that one thing to come up that I forgot about. So as of now, everything's going real good. Tomorrow I'll be on a plane to Jersey, and then I'll be at the beach at my aunt's beach house for 7 days. So looking forward to that.
That sounds great. Do you just relax by the beach, or do you have any activities you do?
I mean, I don't really ever turn off. So I typically will listen to podcasts, read business books, and have my notebook out for brainstorming.
Nice. Sounds pretty good.
Yeah.
How about you, Chris?
This kind of business as usual, I think, for me. No traveling, and just doing the usual. Nothing, just normal day-to-day stuff.
Well, then I have an assignment for you. By next week, you need to do something incredible to tell us about. As for me, I've been just kind of watching the fire situation here in Eagle. It's up here in the mountains of Colorado, and about 20 miles away, there's a big fire that they've called in hundreds of firefighters from places as far-flung as Idaho, and big tankers that drop the red stuff all over the ground last couple of days. And the smoke is in the air, and it's close enough where we've had ash fall on our porch. So not great, not ideal. It's been too hot and dry and windy this summer, more than usual. Hopefully everybody just lays off the fireworks, because this will come out in a couple of weeks, but this is recorded during 4th of July week. Hopefully everyone lays off the fireworks and lays off smoking in the out of doors and flicking cigarettes out of their cars and things like that, so we don't have any more fires. Anyway, last week we talked about securing containerized Docker deployments, or containerized deployments. And as we expected, security is one of those things that you can talk about for a long time. So we cut it off after about 20 minutes, and we had gotten through 2 of 6 phases of the development lifecycle that Chris had learned about during one of the breakout sessions at DockerCon. And it was just such interesting information that I think we should just continue this week and talk about the next 4. Hopefully we'll get through all 4, but if not, security is important, so we'll keep talking about it until we get through it. So, Chris, what's maybe recap just in a few sentences and under a minute if you can, the first 2 so that people can remember, and then we'll jump into number 3. But we don't need to get into the details of the who, what, where, when, and how of the first 2. Just remind us what they were.
Sure, yeah, you bet. So again, this was a talk about trying to match up software development lifecycle to each one of those phases to what you can do from a security standpoint in each one. So they talked about 6 different phases. The first 2 that we talked about last week was the first phase was code. So what you can do there as you're developing the code. And then after that, we went into testing phase and what you can do during as you test that code before it then goes on to the future stages. So I think that brings us to the third step in that process, which is building their actual code. So this is where typically code has been done. You've now tested, verified it. You now need to build your artifacts, and what can you do during that phase of the process? And the big thing that you can do during this phase is scanning of your artifacts to look for any kind of known vulnerabilities, and then also kind of make sure that you are in compliance as well with any particular standards that you may be needing to develop against. For example, like PCI compliance was one of the one of the examples that they brought up that to be PCI compliant, you need critical security patches must be installed within a month of release. So this is something you can definitely do as you build your artifacts. Have your artifacts scanned by these various services that are out there, and there's quite a few of them now that are available. Have them scanned, and that's just one more way that you can just verify the integrity and the security of the code that you're building.
And Chris, this framing and breakdown of how to do security during the development lifecycle is not original thought by Kelsey. So do you happen to have just available who it was that gave this talk and what the name of the talk was, just for people listening, so that we can attribute it correctly?
Mm-hmm, sure. So yeah, this is a breakout session again at DockerCon 2018. It was titled "Don't Have a Meltdown: 6 Practical Tips for Securing Your Container-Based Deployment." And two speakers were Justin Cormack, who's an engineer at Docker, and Liz Rice, a technology evangelist at Aqua Security.
Great, thank you. So, yeah, what's number 3? Where did they go next?
Right. So, and so that was phase 3.
Oops, sorry about that.
No worries. Security is important, but sometimes can be maybe boring and easy to get lose track of. But just to mention too, some of the security tools out there, the scanning tools that you can use. Obviously, Docker itself has their own Docker Trusted Registry feature that's part of Docker EE. And that will do scanning of your images as you push them up to your Docker Hub repo. There's also some open source tools like Microscanner, which is actually an open source tool that comes from Aqua Security, which Liz Rice, one of the speakers, works for. So that's something to check out. There's also another one called Claire that's also open source as well. So again, lots of great tools out there for doing this stuff. Really no reason not to do it. So encourage everyone to get out there and check those out. Yeah. So moving on, the next phase, they broke it out as they called it basically the runtime environment host, if you will. So basically thinking about the actual machines that you're going to be running your containers on. So what can you do there from a security standpoint? And
and Chris, I always like to, since we're sort of fans here of AWS and ECS, I'd like to bring it back to something that we think about. So in this case, this would be EC2 instances in an ECS cluster, right?
Correct.
Right.
Yeah. So it's whatever virtual machine or bare metal, whatever it is that's actually running, you're running your code on. In our case, being that it's containers, so it's wherever you're running Docker and that engine's running. How do you harden that host? And so really the principle here is just you want to reduce your attack surface, and basically just don't make it easy for anyone that might be trying to gain access into your system. They did talk about some of the issues of host versus container vulnerabilities. So basically, files in the container versus files in the host itself, and what ramifications that has there. There are some pretty important considerations on just like the host configuration and how you set that up for running your Docker containers. Some of this stuff is not as applicable to folks, especially if you're running something like we do ECS inside Amazon. Some of this stuff is kind of taken care of for us, but I think nevertheless the overarching theme here is to minimize your attack surface. So
I wanted to talk about that word, attack surface, because I think that's a bit jargony, and it's something that unless you really understand what it means, it doesn't put a picture in your head. So I guess I'll try my best to define it. So if you imagined your running thing being like a shape out there in internet land, some parts of that shape are visible to the rest of the internet, and some parts of it are hidden from the rest of the internet. And it's that those parts that the rest of the internet can see. Maybe it's open ports. Maybe it's machines that have IP addresses that are public. Maybe it's some other things that are visible because of random security vulnerabilities in software, such as software that reaches out and creates reverse proxy to some machine out there in the public. So it's things like that, things that are visible to the rest of the internet that would be your attack surface. Is that a decent description of it? Is there anything I left out?
No, it's definitely very good overall description. I think, like in this particular case, what probably they were focused on is just attack surface basically means software. So the more software you have running on your host, the broader the attack surface is, and the more potential ways someone has to gain access to find a hole to get into it, right? So, and typically that relates to a lot of the stuff that you were talking about. So ports, they're opened usually by software. They're needed by various pieces of software and whatnot. So, the theme here is only have software installed on that host that you actually are using and need. So a lot of times we'll err on the side of convenience for us, and so we'll kind of use a full featured image or AMI that just contains kind of like all the software we need and then some, right? So it's just all right there out of the box. And while that's really convenient and makes life easier for us as DevOps folks, it also means that there's a lot of stuff running on there that we may not even know about, or how to configure it properly, and maybe it does pose a security risk. So,
Chris, can you give examples of a few things that might be convenient to have on a host that maybe shouldn't be on a running host? I was thinking like maybe compilers. Not sure. Various networking tools.
Yeah, I think that's kind of where it boils down to, is just the most. It's going to be like services that are running that are listening for requests that represent a way to kind of get in. Network protocol daemons. It could be things like it's something as simple as like a DNS service, or it could be NTP, or there's various. It could be a kind of like a software package updating service type thing that's just comes as a convenience from some other distro or something like that. So I think just anything that kind of poses a potential door into the system is something to be kind of concerned with, for sure. And then once someone is in the system, then you have to worry about those other things that maybe don't listen. So like a compiler, but maybe having a compiler on there or some other tool like that then gives additional capabilities that makes it easier for someone to cause mayhem.
Right. And, we're diving into this a little bit, despite the fact that you said, maybe this isn't that important if you're using a service like ECS or EKS or Google's managed Kubernetes. It's true that it's not that important when you're using those, because the engineers that created those services on those cloud engines thought about this stuff in advance for you. But I guess, the thing that's coming to my mind is that if you're talking to, a CSO, a chief security officer, or you're talking to a client that's concerned about security, and they start asking hard questions about what you're doing to make sure that things are secure, or even if you're, responding to an RFP and you're talking about all the things that in your software that you're going to do for security, it's nice to be able to say, these are the things that we're thinking about. And one of the things we're thinking about is host security. And these are the types of systems that we're not going to be running on our hosts in production. And the reason why is because we're reducing our attack surface area. And that, makes you sound smart.
Yeah.
Which you got to sound smart in this business.
And well, I mean, there's so much to keep on top of, right? And we talked about this in previous podcasts as well. So, So even if you don't have to do all the work, you should at least be aware of kind of like what the requirements are to play the game, right? And to be able to talk about that stuff.
Yeah. Exactly. Yeah.
Yeah. And so as part of this phase as well, they kind of pointed out there's various, again, tools and benchmarks out there that will help you, have better insight into just how well you are, how secure you are from a host standpoint. So there's a CIS Docker community edition benchmark that you can go and point at your installation and see how it's doing against this. So CIS is Center for Internet Security. So again, they published a benchmark for the Docker CE edition, and that's something that you can run against your host to see how you do. There's also one for Kubernetes, and pretty soon it looks like they'll have one for Docker EE, and then also Windows host operating systems as well. So
that makes me laugh that CIS has something available for Docker CE, but not for Docker EE, and yet Docker EE is the one that maybe big enterprises would be more ready to trust. It's just funny. But go ahead.
I suspect that, again, it might be like surface area type thing, that it's so much easier to put. It's Docker CE is so much smaller, and so fewer parts, and also it's been out there for the longest time as well. Versus Docker EE is changing pretty rapidly. At least that's where most of the innovation that Docker is doing now is going into the energy. So that it may be that Docker is kind of doing more of the work there to get that benchmark in place than it is the CIS.
Right. Interesting. It's funny just because the types of companies that would be most interested in an enterprise edition are the types of companies that have actual CSOs, chief security officers, that think about this stuff sort of 24/7 and have whole teams that work on this stuff.
Indeed.
Hey, this is Rich. You might recognize me as the guy who introduces the show, but is pretty much silent during the meat of the podcast. The truth is, these topics are oftentimes incredibly complex, and I'm just too inexperienced to provide much value. What you might not know is that John and Chris created the training product to help developers of all skill sets get caught up to speed on AWS and Docker. If you're like me and feel underwater in these conversations, head on over to prodockertraining.com and get on the mailing list for the inaugural course. Okay, let's dive back in.
So is there anything else in this phase of building, or is it just those tools that are available to take a look at your surface area and to make sure that you're not running things on your host that you shouldn't be?
Yeah, I think that about sums it up for this. So again, minimize your attack surface area, take advantage of some of the benchmarks that are out there for kind of evaluating just how you're doing in that regard, and just, again, minimal amount of software.
Great. Then moving on, what do we have next?
Right. So that brings us to phase 5, which is the run phase. So now we've coded we've done our coding, we've done our testing, we've built it. We've now hardened the host on which it's going to run on, and so now it's time to run it. So here the theme was least privilege. So you want to give the least amount of privilege to your code that it needs in order to run. So definitely err on being conservative, as opposed to running as root per se. So again, this kind of comes back to everyone knows that this is best practice, like this is what you should do. It does make life more difficult for folks as DevOps to kind of employ this principle. So it's one of those things where I think in practice it doesn't get implemented as rigorously as it should, and we all kind of know that. And maybe it's a little bit of a kind of a dirty secret, but this is definitely one of those things where, hey, you really should just roll up the sleeves and do the extra work and deal with some of that additional inconvenience, because it's so important from a security standpoint. Right. So they gave a lot of examples here of just like what are some of the things that maybe typically happens that kind of are examples of having more privilege than you need, or kind of exposing holes with your runtime environment. One of those would be bind mounts. So this is, I think we've talked about this a few times on previous episodes, with Docker being able to share file system access between the host and the container itself through volume mounts. And we've talked about how this is definitely one of those things that it starts tampering with that purity of container isolation, because you're now opening up that, basically poking a bubble inside that isolation container.
Right.
And there's perhaps some subtle things that can happen that you might not be aware that could happen. So one example they gave was, like, if you did a volume mount and you mounted the /etc directory from your container to your host, by default, your Docker container is going to run as root. And so when inside the container, if you do run the command user add to create a new user from inside the container, what will happen is the user will actually be created on the host as well, right? And this is because it's just going and modifying the /etc users. I believe it's the /etc users file.
Yes.
To add that user to it, right? So because we now have the volume mount, that's where it gets written to, is on that. So now not only do you have a new user inside your container, but it's actually on your host as well, right? And that's obviously a really big moment. So definitely be very, very careful with your bind mounts. You want to very much minimize the area of the file system on the host that you're allowing them to have access to.
That's super interesting. I love that example. And I don't know anybody that's spent a lot of time working with computers that hasn't kind of fallen back on I don't understand that compiler error or that run error. Let me just try again as root. Oh, look, it went away. It's probably not the best way of doing things, but it sure is a common practice.
Yeah, so related to that, also recommended that in your Docker files, set a user. So actually switch from the default root to run a named user that has the appropriate level of permissions. Again, pretty much known best practice. We all know we should do it. The bigger, more popular images will do this. So like the Node.js images, I'm sure Postgres, and all the big ones that have a lot of activity behind them, they do this as best practice. But when it comes to actually building custom software and building your own images with Docker files, I don't see a lot of people taking advantage of this and doing this, and even really understanding what's going on, right?
Yeah, actually help me understand this, because I was thinking while you were talking about this that, containers don't really know anything about their host system. So how can a container tell the host, don't run me as root? It shouldn't even know anything about its host. So how would it have any control over how it's run?
Well, this is the user context inside the container when it's running.
Got it. So the containers own what it's running its own stuff as.
Right.
Okay, got it.
Mm-hmm. Yeah. So by default, it needs a user, right? So by default, it's going to be root if you don't specify something otherwise. And
got it.
All right. So
then the running of the containers themselves also should not probably happen as root, but it is likely that it's happening as whatever user you are, or your runtime scripts run as. So if you're running, for example, on your local host, it's going to probably run under your containers are going to run under your own account, most likely. But if you're running in, some EC2 instance, you'll be running as some user you've created. Do you know whether, for example, ECS creates a special user, like an ECS user on its EC2 instances?
Yeah, and so I think the way it works is it's the Docker image that is instantiating the containers, right? So say you're kicking out, you're running a Docker image and you're using a command line, so you're doing Docker run or whatnot. So that's sending a command to the Docker server. The Docker server is running, right? Like, and that's running on a particular user context. I believe there may be a way to configure the Docker server engine to let it know how, under what context to run these things. It may very well be root. It's an open question for the details on that. I'm not exactly sure how that works. But with ECS, it's at the end of the day, again, it's running the core Docker engine, same, obviously client server model. It has an agent that runs on there as well. It also has the ECS optimized AMI that packages all that up, which is based upon Amazon Linux as well. And it does not.
Chris, that was so subtle that I just need to really clarify it. So you did a very gentle job of correcting me. I said you're running on your local host. I'm running as John C. And I typed Docker run. What you just said tells me, no, my container is not going to be running as a process on my machine owned by John C. It's going to be running as a process on my machine owned by whatever the Docker server is configured to run Docker containers as.
Correct. Yeah, because that's what's actually creating that job, right? It's the Docker server.
Okay, so there will be a short process that is owned by John C. that says, "Hey, Docker server, do something," and then Docker server is going to go run as whoever it should. Okay, cool. I did not know that. Very cool.
Yeah, and then maybe to wrap up this section, there is the -- privileged flag that you can give to Docker when you're running a container. The recommendation there is, like, unless you really need it, don't do that. But that, again, this may be one of those situations where, like, someone is trying to get something to work and, like, they find out, like, oh, I can't do this because of permissions, and search online Stack Overflow or something like that. And it's like, oh, I just had this -- privileged, and boom, it works. And now I'm happy. Right. But it's kind of important to understand the full ramifications of that. It may have been like, all you need to do was, like, give access to a certain directory or something like that, to a user.
Sure.
But instead you've now, opened yourself up to so much more than that. So again, least privilege.
Great. Well, let's wrap it up there. Again, just so much stuff to talk about in terms of security. And I think we've hit on, and I think the thing that I love about this conversation is that it's not just about, oh, you've got software running, how are you going to secure it? It's about, how are you going to do security from beginning to end, from all the way through your design and development and testing and build and run pieces of your software development lifecycle. So thank you very much, Chris. And thanks for joining us, Rich. Have a good week.
All right. Thanks, guys.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/19. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.